Explain Kennedy's theorem. Kennedy's theorem states that if three bodies are in relative motion with each other, they will have three instantaneous centers of rotation, all lying on a straight line. To understand Kennedy's theorem, let's consider a large plane body, R, and pin two smaller plane bodies, P and Q, on it, such that P and Q are free to rotate about the pin. If we rotate P and Q, we see that there is relative motion between the three bodies. Now let's try to determine the eye centers of body P and R, that is PR. Bodies Q and R, that is QR, and bodies P and Q, that is PQ. We know that eye center is the point about which a body rotates relative to some other body at any particular instant. As we see that P and Q rotate about the pins attaching them to the body R, so the eye centers PR and QR will be at their respective pins. Now let's try to determine the third eye center, PQ. If we consider PQ to be on the body P, we see that the velocity vector of P, that is VP, is perpendicular to the line joining PQ and PR. And if point PQ is considered to be on the body Q, we see that the velocity vector of body Q, that is VQ, is also perpendicular to the line joining PQ and QR. From the definition of eye center, we know that the magnitude and direction of velocity vectors of two bodies are equal at their eye center. Here, the direction of velocity vectors VP and VQ would be the same only if point PQ lies on the straight line joining PR and QR. Thus, we see that if the three bodies are in relative motion with each other, they will have three instantaneous centers of rotation, all lying on a straight line. This proves the Kennedy's theorem. The related term is